Welcome to 9.6, Vectors in Space. Our objectives are to find the distance between 2 points in space, find position vectors in space, perform operations on vectors, find more dot product, find the angle between two vectors, and find the direction angles of a vector. So we might be doing more review of these things, but it's because it's an important concept. Find the distance from point 1 at 1, 2, 3 to point 2 at 4, 5, 6. So we're finding the distance between 2 points. This means we'll use our distance formula. So we're going to take x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Find the square root of all of these. What do we get? Well, we have 4 minus 1 and 5 minus 2 and 6 minus 3, which gives us 3 squared plus 3 squared plus 3 squared. So 9 plus 9 plus 9, root 27, which we can reduce to 3 root 3. So the distance from point 1 to point 2 is 3 root 3, whatever units they're moving in. Find the position vector for P and Q. P is 2, negative 1, 3. Q is 0, 3, negative 4. So if you wanted to, you can plot these points and see what's happening. This is actually going to be in 3 space. So we'll have our X, our Y, and our Z. And P is at 2, negative 1, 3. So we've got 1, 2, 1, and here. And then Q is at 0, 3, negative 4, so maybe here. And PQ. So we're looking at that vector. Let's highlight it. That's the vector we're working with, PQ. At least my estimate of it. And we want to find the components of it. So V is going to be x2 minus x1i plus y2 minus y1j plus z2 minus z1k, which gives us 0 minus 2 in our I component, 3 plus 1 in our j component, negative 4 minus 3 in our k component. So we have negative 2i plus 4j minus 7k. And that is this position vector V. Now, if we have two vectors, v and w, we can find all of these different calculations. First, we'll look at the magnitude of v, which we've done before, so this should be a nice review question. V is 6i plus 2j plus 3k, so our magnitude of v is 6 squared plus 2 squared plus 3 squared. Take the square root of it. 36 plus 4 plus 9, which gives us root 49, which is 7. For part B, we have v plus w. So v is 6i plus 2j plus 3k, and we're adding negative I plus 5j minus 2k. So if we combine like terms, we have 6i minus I, which is 5i. 2j plus 5j is 7j. 3k minus 2k is 1k. So 5i plus 7j plus k. That's when we add the two vectors. And this is the vector that gets us from the beginning of v to the end of w. V minus w. So we have 6i plus 2j plus 3k minus negative I plus 5j minus 2k. So we have, I'm going to distribute this negative out to everybody so that way I don't forget about it. 6i plus 2j plus 3k plus I minus 5j plus 2k. 6i plus I is 7i. 2j minus 5j is negative 3j. And 3k plus 2k is 5k. So this is the vector, if we subtract v minus w, this is the vector that would take us from the beginning of v to the end of w. D is 2 times v, so 2 times v was 6i plus 2j plus 3k. So let's distribute that 2. This is 12i plus 4j plus 6k. And that's it. If we doubled that vector, went twice as far, we would end up with 12i plus 4j plus 6k. 3v plus 4w. So this is going to work the same way, just double steps. 3 times our v, which was 6i plus 2j plus 3k, plus 4 times our w, which was negative I plus 5j minus 2k. Let's distribute these. Six times 3 is 18i. 2 times 3 is 6j. 3 times 3, 9k. 4 times negative 1 is negative 4i. 4 times 5, 20j. Negative 8k. Okay, now let's combine our like terms. 18i minus 4i is 14i. 6j plus 20j is 26j. And 9k minus 8k is 1k. And there we go. So if we multiplied these vectors times a constant, and then we added them together, this is where we would end up. This would be the beginning of V to the end of W. So the beginning of the 3 V's and the end of 4 W's. That's the vector 14I plus 26J plus K. Okay, our next example. We're going to find the dot product. This time our vectors have 3 components instead of just 2, but the dot product still works the same. So V dot W is going to be our I components, 1 times 5, plus our J components, -2 times 0, and our K components, 3 times 9. W doesn't have a J, so that's where that 0 came from. 5 plus 0 plus 27 gives us 32. And that's our dot product. This would also tell us these vectors are not orthogonal. Fun fact. Example 5. Find the angle between these vectors, V and W. V is I plus 2J plus 3K, and W is 4I minus K. We have cosine theta equals U dot V over the magnitude of U times the magnitude of V. This will give us the formula so that we can solve for that angle theta. In this case, our U and our V are represented by V and W. So V dot W on the top will give us 1 times 4 plus 2 times 0 plus 3 times -1. On the bottom, we have magnitude of V, so we have 1 squared plus 2 squared plus 3 squared, all under square root. And then we have that multiplying times the magnitude of W, which is 4 squared plus 0 squared plus -1 squared, all under square root. This will simplify to 4 minus 3 over 1 plus 4 plus 9 and 16 plus 1. This will give us 1 over square root 14 times square root 17. Now remember, this is cosine theta, so we need to take cosine inverse to find theta. Cosine inverse of this, and that gives us about 86.3 degrees. Notice we are working in degrees right now, and putting that into your calculator, make sure it's in degree mode. So the angle between these two vectors is 86.3 degrees. All right, for our final example, we'll be looking at the direction angles for V. There are 3 angles that we are going to find for V because we have 3 components. The one thing that's common between all of them, so we're looking for cosine alpha, cosine beta, and cosine lambda. Could probably do that lambda better. Like that. We're looking for these 3 angles. The formula is A over a squared plus b squared plus c squared under a radical, which we should recognize as a over the magnitude of that vector v. And it's going to be similar for the second angle is going to be b over the magnitude and c over the magnitude. So what we need for all of these in order to find solutions is the magnitude. So what's the magnitude of this vector? We're going to have negative 8 squared plus 3 squared plus 2 squared, all under a radical. This is going to give us 64 plus 9 plus 4, radical 77. So for cosine of alpha, in order to find that alpha, A is negative 8 over our magnitude, root 77. If we take the cosine inverse of this, negative 8 over root 77, this is going to give us our alpha angle. So this one is about 156 degrees. Our beta angle, so B is 3, our magnitude, root 77. So if we take our cosine inverse of 3 over root 77, that gives us our beta angle. That's going to be approximately 70 degrees. And C is 2 over root 77. So our lambda angle, 2 over root 77, is approximately 77 degrees. So these are our direction angles. Each component we're able to find the angle that they are moving in each direction.